Okay, so today we are going through and kind of adding the final piece to all of the translations we can do with trig graphs and their inverses, with talking about the period changes. So yesterday we kind of briefly went over kind of what the basic period for your functions are, how that looks like if it's going to be different, but today we're going to practice actually graphing those. So these first three, kind of just to review from yesterday. So remember, if we have 1/2 cosecant theta plus 1, all right, so go through and kind of identify all the things we have. So that plus 1 at the end is a vertical shift. So I can go ahead and add my new x-axis at positive 1. All right, the 1/2 would normally affect amplitude, but remember cosecant actually has no amplitude because it shoots off forever to positive and negative infinity. However, what that will affect is the amplitude of kind of your ghost graph. So for our function, there is actually no amplitude. But if you think about the amplitude for sine, it would have an amplitude of 1/2. So again, if it's helpful for you to sketch that ghost graph, all right, sine would normally start at 0, and if my amplitude is 1/2, then we're only going up 1/2 from the line, back to 0, down 1/2 from the line, back up to 0. And then again, same thing on the other side. Okay? Cosecant itself would obviously not have an amplitude. All right? We have no number that's multiplied by theta, which means we have no period change, and we have no number added or subtracted to theta, so there is no phase shift. Now, one thing you want to pay attention for here is that there is a distinct difference between, let me get off the highlighter, if we had something like cosecant of theta plus 1 versus cosecant of theta plus 1. If the plus 1 were in parentheses, that would be a phase shift. But since there are no parentheses and we only have the plus 1 at the end, that's only a vertical shift. All right? From there, we should be able to fill in where all of our asymptotes would be. All right, and then from essentially 1/2, opening upward, positive 1/2, opening downward, continue that pattern. Okay, so our period did not change, so our normal period for cosecant is 2 pi. Our domain here would be all real numbers, except 0, you can say 0 pi, plus minus pi k. And my range is negative infinity up to positive 1/2. Pick back up on the other side at 1/2. So you can either say 1.5, you can say 3/2, you can say 1.5, decimals are okay, but 1.5 to positive infinity. All right, for the second one, negative 2 secant theta. So the 2 would, again, change the amplitude, except secant itself has no amplitude. So for this graph, none. But it will change the amplitude of the ghost graph, which then inherently changes where kind of your lowest and highest points are, where your curves start, okay? That negative also means it is a reflection, so everything should be reflected over the x-axis, all right? We have no change in period, so that's still 2 pi, and we have no change in vertical shift, so everything still starts from the x-axis, all right? So secant is the reciprocal of cosine. Cosine at 0 would normally start at positive 1, except in this case we have both reflected and changed the amplitude, so really that first point is going to be down at negative 2. All right, then cosine would move to 0, therefore secant is undefined. All right, then again, since we've reflected and changed the amplitude, it would go up to positive 2. Another asymptote, and then back down to -2. All right, repeat that pattern on the other side. All right, so that between the asymptotes, secant looks like so. Because we can see that if we were to sketch your basic cosine would look like this. So we have both reflected and we have changed the amplitude for our reciprocal graph. All right, domain, all real numbers, except our first asymptote is at pi over 2 plus pi k. And our range is -infinity to -2, union +2 to positive infinity. Okay. All right. And then I'm actually going to leave this one for you to practice on your own. So you can try that. Go look at your answers on Schoology, check and make sure you're okay with that. But keep in mind you've got both a reflection and a vertical shift. Okay. All right, so kind of getting in then to the heart of today, kind of adding this last piece in with your period changes. So remember, a period change condenses or expands the graph. So when we looked at this on Monday, this was how we ended up having kind of a tighter knit wave versus a very much elongated wave. All right, so for sine, cosine, cosecant, and secant, your normal period is 2 pi. Because normally the coefficient of theta is just an understood 1 if it is the parent graph. But in this case, whatever our b is, that coefficient of theta, we find the new period, like we talked about yesterday, by taking 2 pi and dividing it by b. All right? And then if we change the period, we also inherently have to change how much we count. So our new tick marks come from dividing those 4 periods by the number 4. Okay? For tangent and cotangent, since they're different, remember their period for the parent function is generally pi. So we take the number in front of theta, divide pi by b, and that gives me my new period. Since those are the only 2 graphs, we get our new tick marks by dividing those by 2. Kind of another way that you can remember the difference is tangent and cotangent are the only trig functions that have t's, t for 2. So that's how you know to take your new period and divide it by 2. The other 4 should then obviously be 4. Okay, so for this first one, all right, you have sine of 2 theta. All right, in this case, my b value is 2. The period for sine normally is 2 pi, so we take 2 pi and we divide it by b, which in our case will give me a single pi. So my new period is pi. So now instead of it taking me until 2 pi to make a full wave, I have condensed it, so it's only going to take me till 1 pi to make a full wave. All right, so this means that we will have new tick marks that come from dividing the new period by 4, which in our case is just pi over 4. Okay, so we already have a tick mark at every pi over 2, but I need to come in and add a tick mark at every pi over 4. So we're essentially doubling the amount of space we have here. Okay. Other than that, nothing about your function has changed. So your amplitude should still be 1 for sine. Sine always starts at 0. So we move from 0 up to 1, back to the line, down to -1, and back to the line. All right, back up to the line, -1, to the line. All right, we can sketch. So we can see that in the time it's taken us to get from 0 to 2 pi, we've really made 2 full rotations. So here was wave 1, and it finished at pi. Then we started wave 2, and it finished at 2 pi. All right. The same in the other direction. So -1 to the line, +1 to the line, -1 to the line, +1 to the line. Okay, so your new tick marks are essentially telling you where kind of your new tick marks, but where you have to count to get to the next space on your graph. Okay, so normally we would count over 1 to pi/2, and that's where our new point would go. But now if my new tick mark is at pi/4, we only go to pi/4 distance and then make our point. All right, that does nothing to our domain, so still -infinity to infinity. And it also does nothing to our range, so still -1 to 1. Okay. All right, the second one, so cosine of 1/2 theta. All right, so in this case, my b value is 1/2. For cosine, your period is normally 2 pi, and I need to divide 2 pi by 1/2. So if I have 2 and I divide by 1/2, that's really the same as 2 times 2. So my new period is going to be 4 pi, which means I am going to expand that graph. Now it's going to take me longer to make a full wave than it did before. All right, my new tick marks come from taking that new period and dividing it by 4, which in our case is just a singular pi. All right, so now I know you can't go through and erase on your paper all the tick marks that you currently have. I think it's easier to kind of go through and almost star them. So I've got to use 0, 0. But then my next tick mark should be over here at pi, which means I'm essentially going to skip pi/2. All right? My next tick mark should be another pi, which is at 2 pi. And then left 1 pi, and then left another pi. So every one that's left unmarked, I'm skipping. I do not count that space. Okay? All right. Cosine, no value in front, which means our amplitude is 1. Cosine normally starts at 1, so here's my first point. The next position is back to the line, which would normally be here. But if I can't use that point anymore, now this is my point back on the line. And then all the way over here at 2 pi is down at -1. So on the left side, at negative pi, we're at 0. And at -2 pi, we're down at -1. So that this is the graph we see currently. Okay? All right, so you might notice that it obviously does not look complete. And that makes sense because if my period is 4 pi, all right, currently, I can see 2 to the left, 2 to the right, which is a total of 4. So imagine that we've started at 0 and we've come up and then back down, and then further than we can see, we would start moving back up and then back down, okay? Which would kind of give you your complete wave, all right? But in this case, we've actually made a full period on this picture from going to -2 to +2. All right, domain is no different. My range in this case is also no different, -1 to 1. All right, tangent of 1/2 theta. All right, so again, my b value is 1/2. Now, tangent's period is normally only a single pi because it's restricted by those asymptotes. So if I take pi and divide it by 1/2, my new period should be 2 pi. Okay? Now, your new tick marks for tangent, remember, are different. You take your new period, but this time we only divide by 2, not by 4. So tangent and cotangent divide by 2, which in this case will give me a singular pi. All right, so again, if it helps to mark, I will definitely use 0. My next tick mark is at pi, and then at 2 pi. And then at -pi and -2 pi. All the other ones that are blank will not be used. Okay? All right, tangent normally starts at 0 on the axis, so that point is still 0. All right? Now, normally, your very next position is an asymptote, but if I can't use that tick